So there are different ways to look at definite integrals, and this is going to take you through looking at it as a function of x. So what if you're just asked to take the antiderivative? You're doing the indefinite integral of 3t squared plus 3t with respect to t. So you would take the antiderivative, and this is just the power rule, so you'd add 1 to the exponent, divide by your new exponent. So this will be a t to the third, and then that 3 would come down, but I'm going to divide by the 3, so that's a coefficient of 1. Plus, this is really a t to the 0 because it's 3 times a 1 that you can't see, so it'll become 3t plus c because we don't know what our c is. If you get asked to do a definite integral, you would use the antiderivative to get the definite integral, so we would know that this is equal to t cubed plus 3t. We don't need the plus c, and we were integrating from 0 to 5. So when you do this, you take the upper limit of integration and evaluate the function there, so 5 cubed plus 3 times 5. And then you would subtract when you plug in the 0, evaluate at 0, so 0 cubed plus 3 times 0. This would give you 125 plus 15, and then this is just 0, so you actually get a number answer out for this one. Well, what if instead of going from 0 to 5, you're going from 0 to x? Well, the process stays the same. So you would take the antiderivative, which we know is t cubed plus 3t, and we're integrating that from 0 to x. So I take my upper limit of integration, which is just an x, and I evaluate my antiderivative there, so that's x cubed plus 3x. And then I know, just like this one, if I evaluate at 0, it goes away. So now my definite integral is actually a function of x. Well, the next question comes in. What if you get asked to take the derivative with respect to x of a definite integral with t's, but there's an x up here? Well, we already know what this is equal to. We know that that is equal to x cubed plus 3x. So it's actually asking, it looks very complicated, but it's saying take the derivative with respect to x of x cubed plus 3x. And we know that that is equal to 3x squared plus 3. And if you look back at our original problem, we have the same expression, but we have t's here, now we have x's. That should make sense. We took the antiderivative, have a variable swap, so the t's all got replaced with x's. Now we're taking the derivative, so we're undoing what we had done, but we have a different variable. So if you have a definite integral with numbers as your limits of integration, you are going to get a number answer. Now, if you have a definite integral with a as a number to x, then you should actually get some function of x. You should have x's in the answer unless they cancel out. So you have two different possibilities, and we'll look at exactly how to determine these and the derivatives of them on the next video.